Welcome back. We are discussing electromagnetism and some of the most important questions which are linked with electromagnetism. And we reached up to this point where we are explaining if a charged particle enters inside a magnetic field with a changing value of the angle, what will be the effect? So here we are. If you look at, can neutron be accelerated in cyclotron? Give a reason. Cyclotron is a device which is used to accelerate charged particles to a high speed. As the neutron is chargeless, it is neutral, so there will be no effect of electric and magnetic field on neutron inside a cyclotron. Thus, a neutron can't be accelerated in a cyclotron. So this was the question: what will happen if you enter a neutron inside a cyclotron? So give a reason. Will it experience a force, or it will not face or experience any type of the force? The answer is it is a device which is used to accelerate charged particle only, because the neutron is chargeless. It is not carrying any type of the charge. So that's why there will be no effect of electric and magnetic field on neutron inside cyclotron. So thus the neutron can't be accelerated in cyclotron. So this is the reason. Next question is a current carrying loop free to turn is placed inside a magnetic field. What will be its orientation relative to be in its equilibrium state? So it is this one is also an easiest question, which we have already discussed in detail. What will happen when there is no effect on the orientation of the loop when it is placed inside uniform magnetic field? We know that the current carrying loop experiences certain torque inside magnetic field, which is given by this theta is equal to NA cos theta. Now the loop will be inside equilibrium if the torque acting on it is zero. This is the most important thing to understand when it will be in equilibrium. It will be the only condition when the torque acting on it is zero. So whoever for getting zero torque, we put the angle 90 degree in this equation. So if it is 90 degree angle, it means the loop is making an angle of 90 degree with the magnetic field. Then for 90 degree, torque will be zero. The plane of the loop should be perpendicular to the magnetic field. Thus, a current carrying loop will be in state of equilibrium when its plane is perpendicular to the magnetic field. So here it is. First of all, we have discussed when a neutron enter inside accelerated inside a cyclotron, what will be the effect on the speed of a neutron. So we have concluded, we have discussed that because cyclotrons works on the principle of uh, charge particle, that is, it has effect on the charge particle, but if there is any type of neutral particle, there will be no effect on the velocity of the neutral particle. The next one is a current carrying loop free to turn is placed inside a uniform magnetic field. What will be its orientation relative to B of magnetic field in equilibrium state? In equilibrium state, this is the most important thing to remember and understand. So this will be the value of the angle, that is, if the plane of the loop is making an angle of 90 degree with the magnetic field, there will be no force acting. So here we are. How, how does a current carrying coil behave like a bar magnet. This one is a current carrying coil, and it is considered that when a current passes through this coil behaves like a bar magnet. One of its end is north, other one will be south. And if you bring the other coil of the same state, you will see there will be force of attraction and repulsion between the two ends. When a current is allowed to flow through the current carrying coil in a magnetic field, when a current is allowed to flow through a current carrying coil, magnetic field is produced inside here. It is magnetic field is produced inside the coil when the current is passed through the coil. So the magnetic lines of forces are straight and parallel. Thus, one face of the coil behaves like a north pole, and the other end behaves like a south pole, like a bar magnet. So here it is. When a current is allowed to pass through current carrying coil, magnetic field is produced. Here is the magnetic field produced. And these magnetic lines of forces are parallel to each other. They are closer to each other. They have direction from one end to another end. One end will be behaving like a north, other one will be acting as a south. And by using the laws, we will be able to understand, and looking at the direction of the current, we will decide what will be the north by using right hand rule, what will be the north and what will be the south. So we use normally a right hand rule. Right hand rule means we will grasp the coil inside our hand. Our finger will show in the direction of the flow of the current. Our thumb will show towards the north pole. So the other pole will be the south pole. So this is the simplest technique to understand how the north and south poles are formed. The direction of magnetic field can be found out by right hand rule, which states that the imagine grasp the current carrying conductor in your right hand, point out the thumb in the direction of the current, curl the finger around the coil, give the direction of the magnetic field. So here it is, the magnetic field lines ori- originate from one face and terminate at the other. So originating face behave like a north pole, and the terminating face behaves like the south pole. So this is another technique to understand which pole is the north pole and which one will be the south pole. By we will use a right hand rule, right hand, and by grasping the coil in our hand, our thumb will show in the direction of the north, and the finger will show the direction of the current moving in the coil. So this is another technique where you can curl your finger with the coil, gives the direction of the magnetic finger will give the direction of the magnetic field, and magnetic lines originate from one face and terminate on the other face. The originating one likes the north and the terminating one likes the south. Like in this case, here it is originating from here, they are starting, and here they are terminating. The starting one will be the north pole, and the terminating will be the south pole. So this is the easiest technique to understand, to find the nature and the direction of the position and the location of north and south pole in case of a current carrying coil or solenoid. It behaves like a bar magnet. It has north and south pole. How these north and south poles are calculated? By using this technique which we have discussed. I thank you very much.